This lesson is called Intro to Trig. What we're going to be able to do is demonstrate application of trig functions by using SOHCAHTOA and secant, cosecant, and cotangent to determine any trig value of a triangle. You'll be able to explain all the trig functions and pronounce them correctly. So for the first part of this lesson, I want us to recall what you learned in geometry. So what you learned is if you have a right triangle like I have here, then immediately across from the right angle is a side length we call the hypotenuse, and I like to abbreviate this as HYP. If you're given another angle, so we called this in geometry, we called this the reference angle, then immediately across from the reference angle was the opposite side. I abbreviate that as OPP, just so I don't have to write that word out every time. And then the additional side is the side that touches theta and the right angle. This side was called the adjacent side. So we had three trig functions that we went over. We had sine of theta, where sine was opposite over hypotenuse. And if you'll recall, the way that we remembered sine was that it was SOH. So sine is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse, and we said that that could be represented as CAH. So cosine is adjacent over hypotenuse. And the last one was tangent. So we said tangent is opposite over adjacent. So this would be TOA. So we remembered this saying of SOHCAHTOA to help us remember how our sides of our triangle were related. So let's go ahead and look at a couple of examples where we're just going to review using SOHCAHTOA. So example number one, we want to find the sine, the cosine, and the tangent of theta. So start by labeling the sides of your triangle. So if we start with hypotenuse, that's the side across from the right angle. The opposite side is across from theta. And then the adjacent side is the remaining side. It's the one that touches both the reference angle and your right angle. So now, write out SOHCAHTOA. This will help you recall how the sides of your triangle are related to the trig functions. So sine of theta, so this is your S, is opposite over hypotenuse. So I'm going to do O over H. So my opposite is 3, and my hypotenuse is 5. So it's 3 over 5, which is 0.6. And you can just leave it as a fraction if you'd like. Cosine of theta, so this is your C. This is adjacent over hypotenuse. So this is A over H. So my adjacent is 4, and my hypotenuse hasn't changed. It's still 5. So as a decimal, this would be about 0.8. And the last one is tangent. So the tangent of theta is opposite over adjacent. So this would be O over A. So opposite is 3, and adjacent is 4. This would be about 0.75. You can leave your answers as fractions. So example 2, same idea. Start by labeling the sides of your triangle. So if I start with my right angle, across from the right angle is your hypotenuse. Then I'm going to go to my reference angle, which is A. Across from the reference angle is your opposite side. And then the last side is your adjacent. So we want the sine, the cosine, and the tangent of A. So we're going to write out SOHCAHTOA. And we're going to find the sine, the cosine, and tangent of A. So sine is opposite over hypotenuse, so O over H. So opposite of A is 40, and the hypotenuse is 41. The cosine of A is adjacent over hypotenuse, so it's A over H. Adjacent, we labeled that as 9, and the hypotenuse still hasn't changed. It's 41 here. And then the last one is the tangent of A. So this is opposite over adjacent. So opposite is 40, and the adjacent is 9. So this would be 40 over 9. So these are your three trig functions for example 2. So now what we're going to see is that there's actually 3 more additional trig functions in addition to sine, cosine, and tangent. So there are three additional trig functions. The first one is abbreviated CSC, and this means cosecant. And the way that we pronounce this is cosecant. So the next additional trig function is abbreviated SEC, and it's pronounced secant. So the way that we say it is SEE cant. So this is secant. And the last one is COT, which means cotangent. And we pronounce this as cotangent. So these are the three additional trig functions, cosecant, secant, and cotangent. And in the next slide, I'm going to explain what these mean. So the three additional trig functions, cosecant of x is equal to 1 divided by the sine of x. So what this is really saying, I'm going to do the reciprocal of sine of x. So I'm just going to write out SOHCAHTOA, so we have it. If remember, sine is opposite over hypotenuse, so the reciprocal of that would be hypotenuse over opposite. Secant of x is 1 divided by the cosine of x. So this is the reciprocal of cosine. So looking at SOHCAHTOA, we know that cosine is adjacent over hypotenuse, so the reciprocal of that will be hypotenuse over adjacent. And then the last one is the cotangent of x is 1 divided by the tangent of x. This means we're going to do the reciprocal of tangent. So if we look at SOHCAHTOA, we know tangent's opposite over adjacent. So the reciprocal of that would be adjacent divided by opposite. So go ahead and pause the video if you need to finish copying this down, and we'll look at our first example of this. So example 3, find all 6 trig values for the triangle below based on the angle. So this is my reference angle. So let's start by identifying the sides of my triangle. So across from the right angle is the hypotenuse, so that would be 15. Across from my reference angle is the opposite, so that would be 12. And my adjacent is 9. So I'm just going to write out SOHCAHTOA so that I have it when I identify my trig functions. So I'm going to start with sine of theta. So remember, sine is opposite over hypotenuse, so I'm going to do O over H. So opposite is 12, and the hypotenuse is 15. And you do need to reduce the fraction. So these are both divisible by 3, so this will be 4/5. Cosine of theta is adjacent over hypotenuse, so A over H. So that would be 9 over 15. Again, these are both numbers divisible by 3, so this would be 3 over 5. So if you can simplify the fraction, make sure you do that. So tangent of theta is opposite over adjacent, O over A. So opposite is 12, and adjacent is 9. These are, again, both divisible by 3. This would be 4/3. So make sure you reduce the fractions. Cosecant, secant, and cotangent. So now the next 3 trig functions. So we know that sine and cosecant are related. Cosecant is the reciprocal of sine, so this would be hypotenuse over opposite. So if I go to my picture, I look at my hypotenuse is 15, my opposite is 12. So this would be 5/4. Or you could just take the reciprocal of the fraction that you had for sine. Secant and cosine are related. So secant's the reciprocal of cosine. So this would be hypotenuse over adjacent, H over A. So hypotenuse is 15. The adjacent is 9. So this reduces to 5/3. Again, you could have just taken the reciprocal of the cosine fraction. But you got to be careful, because if you have square roots, then taking the reciprocal is not necessarily the best idea. And we'll see that in the next example. Tangent and cotangent. So the cotangent and tangent are related because cotangent is the reciprocal of tangent. It's adjacent over opposite. So my adjacent is 9, and my opposite is 12. So this reduces to 3/4. Again, you could have just taken the reciprocal of 4/3, which was tangent, and you could have got that. So example 4, just like we did in example 3, we're going to find the 6 trig values for the triangle. So start off by labeling the hypotenuse. Remember, you're going to find your right angle. The side directly across from the right angle is the hypotenuse. Then label the side across from your reference angle. So my reference angle that I'm given is theta. So the side across from that is my opposite side. And then the adjacent side is the side that touches the reference angle and the right angle. So this is my adjacent. So I'm going to write out SOHCAHTOA just so that I have it. And I'm going to find the first 3 trig functions. So sine, remember, is opposite over hypotenuse. So opposite is 7. And the hypotenuse is square root of 58. However, we do not want to leave square roots in the denominator. So we will multiply both sides by square root of 58 divided by itself. So what happens, remember, is these square roots cancel, and I get 7 square root of 58 over 58. So just don't leave square roots in the denominator. Cosine of theta, remember, cosine is adjacent over hypotenuse, so a over h. So this will be 3 over square root of 58. Again, don't leave square roots in the bottom. So I'm going to multiply by root 58 over square root of 58. And this will get me 3 square root of 58 over 58. Tangent. So tangent, this is opposite over adjacent, so O over A. Opposite is 7. And adjacent is 3, so it's a 7 over 3. Cosecant. So remember, cosecant and sine, these two are related. So cosecant is the reciprocal of sine, so this is hypotenuse over opposite. So the hypotenuse is square root of 58. And opposite is 7. Secant of theta, remember, secant's related to cosine, is the reciprocal, so this is h over a. So the hypotenuse is square root of 58, and the adjacent is 3. And the last one, the cotangent. Cotangent is related to tangent, so it's the reciprocal, so this is adjacent over opposite. So adjacent is 3, and opposite is 7. So this is 3 over 7. So these are your 6 trig functions for example number 4. So that's the problem I want to look at is going to require us to use the Pythagorean theorem. So I'm just going to sketch this out real quick for you. So if I have a right triangle with side lengths A, B, and C, where C is the hypotenuse, C always represents the hypotenuse. If I want to figure out one of the side lengths, I can use the Pythagorean theorem, which is a squared plus b squared equals c squared. Remember, c is the hypotenuse. So we're going to use this to help us with the next question. So this is number 5. So we have side lengths 14 and 8, and we want to find the hypotenuse. We don't know the hypotenuse in this triangle. So that's the first thing we're going to need to do. So we're going to write down the Pythagorean theorem, a squared plus b squared equals c squared. And we're going to plug in, we'll just say 14 for A and 48 for B. Remember, the C represents the hypotenuse, which is what we don't know. This is your C. So if we plug this stuff into the calculator, what you're going to get is 196 plus 2,304 equals C squared. When you add these up, you get 2,500 equals C squared. Take the square root of both sides, and you get that 50 equals C. So this is the length of the hypotenuse. So I'm going to go back to the triangle, pause the video if you need to finish this. I'm going to go back to the triangle and label the hypotenuse as 50. From my reference angle F now, I can label the opposite side and the adjacent side. So I have the hypotenuse is 50, the opposite side is 48, and the adjacent side is 14. So I want you to find the 6 trig functions for number 5. Pause the video and give it a try. Hopefully you gave this one a try. I have the answers for the 6 trig functions here on your screen, so you can check your work with mine. So you should be able to complete the Math Excel assignment called Intro to Trig.